the zero product property. If the product of two or more numbers equals 0, then either one or both of those numbers is equal to 0. Let me show you what I mean. If A times B equals 0, then what could A or B be? Well, either A equals 0, and then B can be anything. It could be 47 or negative 102, but anything times 0 equals 0. The other option is that B equals 0. Again, if B is equal to 0, then A could be anything, including 0. So the zero product property says that if A times B equals 0, then either of those two things must be 0. Here's an example of two things multiplied by each other. I have x times x minus 1. And these two things multiplied together equals 0. And what we just saw from the zero product property is either that x is equal to 0, or, let me write the or the other item there, x minus 1 is equal to 0. So either x equals 0 or x minus 1 equals 0, but x minus 1 equals 0, we can just simplify this equation, add 1 to each side, and we get x equals 1. So the solution to this equation is x equals 0 or x equals 1. If either of those two things are true, then our equation holds. In other words, x times x minus 1 is equal to 0. And so let's run through a couple of examples, or I just want to show you what that looks like in the equation. So if x is equal to 0, then our equation looks like 0 times 0 minus 1 equals 0. So that means we have 0 times negative 1 equals 0. And is that true? You bet it is. 0 times anything is equal to 0. Or if x equals 1, what does our equation look like? Well, it looks like 1 times 1 minus 1 equals 0. Is that true? Well, we can simplify the brackets. 1 minus 1 is equal to 0, so I have 1 times 0 equals 0. Is that true? Absolutely. So that's what the zero product rule allows us to do. It allows us to solve equations where you have two things multiplied together and get 0. And even as those two things that are being multiplied together, if they equal 0, it doesn't matter how complicated they get, the zero product rule still tells us that either 5n minus 2 is equal to 0, or 6n minus 1 equals 0. If either of those two things are true, then when you multiply them together, you get 0. So we can simplify each of these equations. How do we do that? Well, we add 2 to each side on this one. So you have 5n equals 2, then divide each side by 5, and you get n equals 2 over 5. So that's one solution to this equation. The other solution would come from the other equation that we have over here in purple. So we add 1 to each side, get 6n equals 1, divide by 6, and we get n equals 1/6. So here's our solution. So again, it doesn't really matter how complicated the interior of the brackets are. If you have these two things multiplied together and they equal 0, then either all the stuff inside the first brackets equals 0, or all the stuff inside the second brackets equals 0. And there's nothing stopping us from extending this to more items. If you have A times B times C equals 0, then at least one of those items has to be equal to 0. So the solution to this equation will be that either 3p minus 8 equals 0, 22p plus 13 equals 0, or 9p equals 0. Any of those three are solutions to this equation. And in particular, to solve these equations, you need to say all the possible solutions. So what are all the possible values of p that solve the equation? Well, let's go through. I'm going to add 8 to each side here. So I have 3p equals 8, p equals 8 over 3. So that's one possible solution. This guy, I'll take 13 from each side and then divide by 22. So negative 13 over 22 is a solution. Or here, if I divide each side by 9, well, 0 divided by 9 is 0, so p is equal to 0. So here are my three solutions. Oops. And any of those three, sort of on a diagonal there, any of those three are a solution to this equation.